Hello my dear children, this is Rijuan PSK classes, Semiconductors. We were doing voltage regulator by a Zener diode, okay, and this was confusing. I know it was confusing. The working of a circuit is not easy to grasp, but maybe we will do couple of problems. After that I think this will be okay, right. Now Zener diode is connected as a voltage regulator. The working should be understood. Working. The output taken across the load resistor. The output is taken across the load resistor. You can see that VO. This is the output across the load resistor. When the input DC increases, this voltage increases. Beyond the breakdown voltage of the Zener, the current through the Zener diode will increase. The current through the Zener will increase, but the current through the load and the voltage across the load will not increase. Okay. Now, everything comes from the Zener reverse break. At the Zener reverse breakdown voltage, what happens? When the Zener reverse breakdown voltage is equal to its normal voltage, then current through that can increase, but the voltage will not increase. That's the point that you need to understand. Okay. What to understand, how to understand. Listen carefully. In the Zener diode, take the reverse bias. You have to concentrate only here. What is this voltage called? It is called Zener voltage. At Zener voltage, what is happening? At Zener voltage, the voltage remains fixed, but the current can take any value. That's what I said. When the graph is drawn downward like this one, what does it mean? At a constant voltage, current increases. That is the property of Zener diode. Once this is reached, once the Zener breakdown voltage is reached, then the current through the diode can increase without a change in the voltage. So, what is the maximum voltage that this load can get? What is the maximum it can get? The maximum is equal to Zener voltage. Suppose this Zener has got a voltage Vz equal to 6, then the maximum voltage across RL will be equal to 6. Whatever be the value here, this will be 6. It can't go more than that one. This is how it regulates. Okay, don't worry. Let us work out. Let us work out. Now these are the points that you need to understand. Okay, I will draw the diagram here. Physically, when we draw the diagram, we will understand it. Okay, I have a device which is represented as RL, the load. I want to limit the voltage across it. Suppose I want to limit the voltage to 6 volt. What should I do? I should connect a Zener here. I should connect a Zener. How is it connected? It is connected like this. This is the Zener. Its P side at the bottom, N side at the top. Fine. Then this is connected through a resistor to the voltage. This should be positive, this should be negative. So you can see that minus connected to P side, this is reverse biased. Now this Zener has got a breakdown voltage of 6. Clear. Now what is the maximum voltage across the load? That's the first point. Voltage across the load resistor maximum is always equal to Zener voltage. That means here in my example, the voltage across the load will be equal to 6 or less, not more. 6 volt or less, not more than that one. Regulated, stabilized. What is the current here? The current through this one, I can call it as IL. You know current, you want current, you know resistance and you know voltage. Right. So, load current is calculated. Load current IL is equal to, what is the voltage across that one? Maximum is Vz divided by RL. In my case, 6 by RL. Okay. Now, see here you are giving an input voltage V. Between these 2 points, the voltage is 6. So, this voltage should be applied voltage minus this 6 volt. Or in general case, it should be V minus Vz. Voltage across series resistance, VDC minus Vz. Concept from current electricity. So what is the current through this thing? You know the potential difference, you know the resistance Rs, then you know the main current is nothing but V minus Vz divided by Rs. Now you see here, there is a current coming and IL is going. What is this current? This current is called the Zener current. How to find out Zener current? Zener current is nothing but main current minus the load current. There is a question here. What is the value of output voltage V0 in the circuit shown in the figure? See this. It is written 6 volt. That means your Zener will break down at 6 volt. It is reverse connected. 6 volt. Input is more, 20. Will this 20 available here? No. The voltage maximum available between here, this point is 6 volt. That is the first concept that you should learn. What is the maximum available voltage there? That is equal to 6 volt. Next one. In the given circuit, current through the resistor 2K. I want the current through this one. Very simple. Look at the circuit. The Zener will break down at 12. Applied voltage is more than that one. So 20 and 12. This Zener maximum voltage is 12 and that is where you have connected this 2K. So the maximum voltage across 2K. Maximum potential difference across 2K equal to Zener breakdown voltage. Which is equal to 12 volt. So what is the current through the load RL? That is VZ by RL, which is 12 divided by, what is the resistance? That is 2K. So this is giving you 6 milliampere. Okay, what is the voltage here? What is the voltage here? Very simple, 20 minus 12, that is the voltage here. This voltage will become 20 minus 12, 8 volt. So what is the current here? Let me mark this current as I. You know the voltage and you know the resistance. So that current I is nothing but 8 divided by 1K, which is equal to 8 milliampere. Aha. See this? 8 milliampere is coming here and 6 milliampere is going here. So what is the current through the Zener? It's the difference, 8 minus 6, that is equal to 2 milliampere. Do this again. Do this again till you study. Don't worry, we have other questions similar to this thing. Now the circuit configuration appears to be different, but functionally it is the same. ഇതിൽ ഏത് റെസിസ്റ്റൻസിൻ്റെ വോൾട്ടേജ് ആണ് റെഗുലേറ്റ് ചെയ്യുന്നത്? വിച്ച് റെസിസ്റ്റൻസ് വോൾട്ടേജ് ഇസ് റെഗുലേറ്റഡ് ഹിയർ? How do you understand that one? You go and look at the terminals of the diode. The diode terminal, one terminal connected here, other terminal connected here. So that is R2. You are controlling, limiting the voltage across this R2. Because one end of the diode is connected here, other end is connected here. So this is the resistor where you are controlling the voltage. And how much maximum voltage it can get? It can get only a maximum of how much? 10 volt. So the maximum voltage across R2 is 10 volt. And what is the maximum voltage across R1? Simple. Applied voltage is how much? 15 minus 10. So this is getting only 5 volt. Now let us calculate everything. Let us calculate everything. In the circuit given, current through Zener diode is. Before that, you should study those equations I told you. I told you different equations. You remember that? What was it? First of all, I said voltage across the load which will be equal to voltage across the Zener, and in this case that is equal to 10 volt. And current through the load is equal to, I told you the equation VZ by RL. And that is nothing but 10 divided, what is RL here? Which is RL in this case? That is R2. That is 1500. So that will give you 1 by 150 ampere. Okay. Now what is the voltage across the resistance R1? Voltage across resistance R1 is nothing but 15 minus 10, which is equal to 5 volt. So what is the current I? How to find current I? This current I is flowing through this resistor, and you know the voltage across this resistor is 5 volt and the resistance is 500 ohm. So we can say this equation is V applied minus Vz divided by Rs. That was the equation, and that is 15 minus 10 divided by 500. That is 5 by 500 which is 1 by 100. Okay. I told you this current will come here and split into two current. One will go through load, another go through the Zener. What is the equation for Zener current? Zener current is nothing but the main current minus the load current. And what was the main current? It was 1 by 100 minus 1 by 150. So this will give you 50. 150 minus 100, which is 50, divided by, cross multiply, 150 minus, should I write that? No need, you can do that, right? This is 1 by 100, so this will give you 150 minus 100 is equal to 50, divided by 100 into 150. 50 cancel here, this will become 1 by 300 milliampere. 1 by 300 milliampere. That is how you calculate it. Okay. Zener current. I think, see, is there anything, any value? 500, 1500, 1 by 300. 1 by 300 ampere, I'm sorry, not milliampere, 1 by 300 ampere. 1 by 300 ampere. So that will give you 3.33 milliampere. This is not milliampere, it's ampere, 1 by 300 ampere. Okay, so that part is over. Okay, now Zener, you can expect numericals both in board examination as well as in end examination. All you have to study is this thing. Where is that? 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 This set of equations, this one. This is what you need to study, this set of equations. This set of equation is what you need to solve any question in Zener. Be confident. Now special diodes, we are continuing special diodes. Now the title is optoelectronic junction devices. Heavy name, optoelectronic. Opto means light. So these are electronic devices which are related to light for its working. Means either the input part or the output part we use light. That's why it's called optoelectronic, electronics and light. Okay. There are three basic devices. Okay, first one is photodiode, second is light emitting diode, and the third one is solar cell. All of them are based on photoexcitation. Photoexcitation means you studied electron hole pair can be created by giving energy. If this energy is given in the form of light, then it is called optical stimulation, photoexcitation. Okay. Semiconductor diodes in which charge carriers are generated, means electron hole pairs are generated by photons by light, is called optoelectronic junction devices. Photodiode is used to detect light, variation in the intensity of light is called detecting optical signal, photodetector. Light emitting diode produces light using electricity. Solar cell, reverse, it produces electricity using light. These two are quite opposite to that. So let us start from a photodiode. A photodiode is a special purpose PN junction diode which is operated in the reverse bias, just like your Zener diode, operated in the reverse bias. It has got a structure so that light can directly fall to that PN junction. This is a practical thing, it's a very small device. You can see there is a transparent top where light can fall. When light falls, it can work. Its symbol is like this, an ordinary diode, but it is ready to take light. It is ready to take light. P side and N side. Okay. In a circuit, we always connect that in the reverse bias. You can see that P side is connected to negative, N side is connected to positive. And light falls, what will happen? When light falls, electron hole pairs are created. And this electron hole pair will produce a reverse current. You can see that when photon falls on the device, electron hole pairs are created. What is the condition? Condition is this, the energy of the photon should be greater than the energy gap. Okay, and this will produce a current in the device. Okay. Why is it connected in the reverse bias? I'll tell you what it is. Okay. Before that, see this characteristic curve. Each of these lines represents a reverse bias characteristic but for different intensity of the incident light. When the light intensity increases, the number of photons incident will increase, which will create more electron hole pair. So when intensity of the incident light is increased, what will happen? More current will be produced. So you can see I3 has got a large current. I3 has got a large current, that means I3 is receiving more intensity. So I3 is greater than I2, greater than I1. Intensity is, as intensity increases, the current increases. It is operated in the reverse bias. Okay. Now listen, here there are two currents, listen carefully. When you have a connection like this one, there are two currents. Even without light, the battery will produce a current. That's called a biasing current. With the light, the optical current. So there are two currents. One is the current due to the biasing battery, another is due to light. Okay. You want to detect the variation in the intensity of the light. Light is falling, you want to find the intensity variation of the light. And when light's intensity varies, the current in the device will vary. Okay. So by measuring the variation in the current in the device, you can measure the variation in the intensity of light. What is the use of photodiode? It is to detect the variation in the intensity of light. How does it work? When the intensity of the light falling varies, the number of electron hole pair will change. That will change the optical current. By measuring the variation in the optical current, we can measure the variation in the light. That's it. Okay. Why is it reverse biased? Very simple. You can work this in the forward bias also. The problem is this, in the forward bias, the battery will produce a very large current and the optical current will be very, very small. So small optical current in a very large forward current will be difficult to notice. But in the reverse bias, the biasing current is also small. The optical current is also small. So the percentage variation will be easy to identify. If I say like this, if I give you an example, okay, assume that the biasing battery produces 100 milliampere current and the optical, the photons produces 0.1 microampere current. 0.1 microampere become a very small percentage of this current. So variation in this one will not become easily noticed. But suppose instead of the forward large current, we are using a reverse current which is like a 1 microampere and same photo current 0.1 microampere. You can see that this 0.1 microampere become almost 10% of this current. So a slight variation in this one will be easily noticed here. Why photodiode is used in the reverse bias? Answer: small variation in the optical current is easy to detect with a small reverse bias current than a large forward bias current. There is no other reason. It is asked as a question in NCERT, answered also in NCERT. Working is explained when the photons are incident, electron hole pairs are generated and they produce a current. The magnitude of the photocurrent depends on the intensity of the incident light. So if you want to measure the intensity, you measure the magnitude of the photocurrent. Why is it operated in the reverse bias? The fractional change due to the photo effects on the minority carrier dominated reverse bias current is more easily measurable than the fractional change in the forward bias current. Fractional change in the reverse bias current is more than the fractional current in the forward bias. Now application. These are used in many areas like in fire and smoke detectors. If there is a variation in the light intensity, then this device can sense it and produce an alarm. Used in electronic devices like TV, all those devices. Industrial production line. This is like suppose that you are running a factory like Horlicks or Boost, and the cans are moving on that one. You can count the number of cans by simply using a setup like this one. There is a counter, there is a photodiode, there is a light source. Light will hit the diode and there will be a certain current in the counter. But when a can comes in between, light stops, variation in the light changes the current in the device, and that is sensed by the counter, so it can sense that one object has gone through. So it can be used to count them. In photography, we use a device like this, a light meter. Okay, this is used in photography to measure whether light is available everywhere. This is also based on such devices, because this is the area where it takes light and that is converted into current, and you can see that as a display in the device, in various devices. Colorful world. Colorful world. Now the lighting system everywhere is changing. We are using these small, tiny, bright devices called LEDs, light emitting diodes. Now tube lights, compact CFL, all those things, and light strips, LED strips. You have that in your house, right? The decoration, everything. See, now Christmas, New Year, all those functions become so colorful because of these things. They consume very small amount of power. They run for a long time. Hassle free. These are called light emitting diodes. Light emitting diode. It's a diode. See the symbol. Ordinary diode with a light coming out of that one. Photodiode was absorbing it. This is releasing it. And what is a light emitting diode? It's a heavily doped PN junction which is always used in the forward bias. Okay. The concept is this. It converts electrical energy into light energy based on the principle of energy radiation due to electron-hole recombination. You studied that when electron and hole recombine, they release energy. And here it releases in the form of light. So the energy gap should be according to that. Because if you want visible light, the energy must be like 1.8 electron volt to 3.1 electron volt. 1.8 to 3.1 electron volt. So ordinary silicon and germanium cannot do this because their energy gap is around 1 electron volt. So they can produce only infrared waves which are not visible. So you go for special kind of compounds like gallium arsenide, etc., which actually produces light. Okay. Photons with energy equal to energy gap. Okay, photons with energy equal to or slightly less than band gap are emitted. That means if you want an equation for this, I can say in a diode, in an LED, energy released is slightly less than or equal to energy gap. Or you can say the energy of the photon is slightly less than or equal to energy gap. This is because of some absorption happening during the process. Okay. So what is a light emitting diode? What is the principle of its operation? Light emitting diode is a heavily doped PN junction diode which under forward bias produces light. Principle of operation, energy radiation to electron hole recombination. What kind of energy gap is required, or what kind of waves are produced, what kind of colors are produced, depends on the energy gap. Fine. What are the advantages? You don't get any numericals from this one. Advantages, they consume very small amount of power and they are almost instantaneous. You turn it on, at that instant they come up bright. There is no warm up period. You must have seen that the street lights which use a sodium vapor lamp, they have a warm up period. The moment they turned on, they wouldn't produce light. They take some amount of time. But this will not take any time at all. The bandwidth are 100 Armstrong to 500 Armstrong. Okay. That means the variation is very less. See, this is not the wavelength produced. Wavelength produced is between 400 to 700 Armstrong, but the bandwidth, the variation in a particular light is very small. Light is nearly monochromatic. Then it's a single color can be produced. Either red, blue, yellow, etc. can be produced. Long life. It can work for years and years and years. Rugged means there are no mechanical moving part. Even if you throw that to the ground, it will not break. Fast on-off switching capability. I said it's very fast in responding. Okay. Now, other advantage technically is that spectral range of visible light is from about 0.4 to 0.7 micrometer. That means 4000 Armstrong to 7000 Armstrong. Energy of photon is from 3 to 1.8 electron volt. Okay, that is visible. Semiconductor used for fabrication of visible LED must be having a band gap of 1.8. Manasilayo. If your light is visible, Violet light means energy is 3 electron volt, red light means 1.8 electron volt. So if you want to produce visible light, energy of the photon must be in that range and the energy gap must be also in that range. So minimum energy gap is 1.8. Can silicon produce visible light? Answer no, because the energy gap of silicon is around 1 electron volt, it can produce it. LEDs are used in many areas, no need to say. The LEDs are used in automobile vehicle lighting, street lighting, domestic lighting, display units, everywhere. Okay, so many areas. And we are going to talk about the other one. I think this is very familiar to you. These are called solar panels. Each of them absorbs light, produces electricity. These are the only unbiased semiconductor diode, because all other diode requires an extra battery, but this does not require that one because this produces energy, solar cell. This is the future of the world. Now solar energy production is costly, but years after, when other energy sources become depleted, then you will have to depend only on this. Then unless some new fuel is produced, then you have to depend on this. Okay. What is a solar cell? It's a PN junction that converts light energy into electrical energy. External bias is not required, no extra battery required. What is the principle? Again same thing, the production of electron hole pair due to incident radiation near the junction, just like the photodiode. It has a very thin N region with a large surface area. Okay, these are the basic idea. You can see this, this is a basic structure of a solar cell. There is a P layer and N layer. And N layer is made very thin so that light can directly fall on the junction and produce. See, N layer, P layer, light is falling. When light falls on it, what will happen? Electron hole pairs are created. That's how it works. Now in a solar cell, its operation has got 3 steps. So this is a solar cell. P, this is the junction area, light is falling and there is no biasing battery. You can see there is only a circuit connector. Fine. Now when light falls on it, three things will happen. First one, generation of electron hole pair. When light falls on it, if the energy of the photon is sufficient, it will produce an electron and a hole. Electron and a hole. First point. Second point, you know that there is an electric field across the junction. There is an electric field across the junction from the E side to the N side to the P side. So when electrons and holes are produced, electron will be attracted opposite to the field, holes will be pushed towards in the direction of the field. So electron will go to this point and hole will go to this point. So this will become negatively charged, this will become positively charged. Okay. Separation of electron and holes due to the electric field across the depletion region. That is the second step. Now the third step, if you have an external circuit connected, then this positive and negative charges will flow towards each other and they will produce a current. That is the third one. Collection of the electrons reaching the N side and the P side by contact plates. 3 steps. 1, generation. Second one, separation and collection of electron hole pair. Fine. Now in a PN junction, in a solar cell, which is positive, which is negative. P is positive and N is negative, and current will flow like this from N side to P side, like this. Okay. Now this external resistance can be varied from 0 to infinity. 0 to infinity. If it is 0, then your solar cell will be directly connected like this. Okay, current will flow from the P side to the N side, like this. Clear? This is drawn in the 4th quadrant. This is drawn in the 4th quadrant. When there is no resistance, we call it as a short circuit. When there is short circuit, the potential difference will become 0. You studied this in current electricity. Short circuited cell, terminal voltage will become 0. There will be a large current flowing. That current is marked here. This is called ISC, short circuit current. I said resistance can vary from 0 to infinity. This is resistance equal to 0. Now what is the meaning of resistance infinity? Resistance infinity means you open circuit it. When it is open circuited, there is a voltage available, but there is no current. So that point is available here. There is a voltage but current is 0. Then if you have other values for resistance in between, I said it can vary from 0 to infinity. Then for other values like 1 ohm, 2 ohm, 5 ohm, 10 ohm, etc., you will get different points and you get a curve like this one. This is the characteristic curve for a solar cell. This is the only characteristic that comes in the fourth quadrant. Normally diode characteristic comes in the first and the third, but this is only where it comes in the fourth quadrant. Okay. So see this graph, open circuit voltage and short circuit current. Okay. Now what kind of a material will you select for making solar cell? Criteria for selection. Energy gap must be between 1 and 1.8. Only the reason is that sunlight is producing most of the energy in that region. That's why you always go for that energy gap. Okay. High optical absorption. Light should fall on it and the material should be able to absorb it. That's why we go for high optical absorption. Third one, it should have a high conductivity. Resistance should be less. It should be easily available at low cost. So these are the different criteria for selection of the material. The first point I think I will explain in this question, NCERT question. Why silicon and gallium arsenide are preferred material for solar cell? Okay, for silicon energy gap is 1.1, for gallium arsenide is 1.53. Fine. And this is a solar spectrum, the energy incident versus the energy of the photon. Maximum amount of energy comes in the form of photons having energy 1.5 electron volt, and that is thermal energy, infrared. That's why sunlight is hot. So if you want to absorb and produce maximum energy, then the energy gap should be able to convert these photons into electricity. That's why we go for silicon or gallium arsenide. Gallium arsenide 1.5, silicon 1.1, between 1 and point. That's why we said it should be between 1 and 1.8. Okay. So these are the criteria. Work out this question from NCERT. Thank you for your time. We have come to the end of diodes. In the next class, we will come with an amazing device which changed the world. Till then, bye.